Hello and good afternoon, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this afternoon's video tutorial is going to be on lab activity, and this is going to be our Cisco Networking Academy Lab 6-1, where we're going to be taking a look. I'm going to break this into two parts. The first part is going to be the HSRP portion, and then the second part we're going to be taking a look at the Virtual Routing Redundancy Protocol, VRRP. Now, the first 6 steps have us basically configure all of the trunking in this diagram that you see here on the screen. This is actually how everything is cabled up, and we have hosts basically hanging off of every single switch. And what I'm going to be doing is basically switching the cables out each time we need to work with a host. So we have a host here, we've got a host hanging off of here, and these hosts are all in different VLANs and they'll be used for different things. The one key thing is that they're always in FA06, so that's the port that all of the hosts are currently in. And again, it would have been nice, I'm not sure, not a big fan of the use of this port channel here. All the ether channeling is set up. We're using PAG-P throughout because in a realistic environment, you would not have your access layer switches connected like that. You would have it more as your classic access distro configuration with an ether channel up to DLSW02 and one to DLSW01 for each of the access layer switches. However, this link is in play during the lab. So I'm actually going to be starting at step number 7. Again, the reason we're starting at step number 7 is because steps 1 through 6 took about 15 minutes to manually configure and really doesn't deal with anything other than configuring all of these ether channels that we have here between all of the switches. And I've even done the VTP configuration. So again, we want to focus on the HSRP portion here and not spend an inordinate amount of time just walking through and doing the basic configuration that's going to be required to get us up and running. So let's go ahead and dive in here on the command line. And we're going to start out on DLSW01. And so here we are in this distribution layer switch. We'll go from user exec to privilege exec, and now we're going to be doing inter VLAN routing. So if we're in global config, we want to say IP routing. Now we're going to add in a loopback interface, and this is going to basically simulate the internet and give us an address that we can ping. So we'll say IP address 209.165.200.254, and we're just going to make this a /24. Now the loopbacks are always up. I always just type no shut in just out of habit so that further down the road I don't forget to do it on an interface where it does require it. Okay, so we've configured a series of VLANs. If I say do show VLAN brief, these are the VLANs that we're looking at right now. We've got VLAN 10, 20, 30, 40, and then we have our management VLAN, which is VLAN 99. And you'll notice that on DLSW01, we've got the FA106. Port FA106 is, if we do need to plug in the MacBook, it's going to go into that port right there, which would be used for that management VLAN. All right, so now let's go ahead and set up what we would consider to be our HSRP environment. So we're going to go into interface VLAN 99 for the management network. Now remember, the Cisco Learning Labs activities had us configure HSRP, and they had us do it on physical routed interfaces, on routers, right? So layer 3 interfaces on routers. Well, remember, the switched virtual interface is a multi-layer switches version of a physical routed port. It's just that it's being done in software. So when I say interface VLAN 99, let's give it an address here. We'll say IP address 172.16.99.1. Now remember, that is the IP address of the switch virtual interface. That is not the HSRP standby address. or the virtual IP that floats between the two distribution layer switches. So we're going to say standby 99. The IP address is going to be 172.16.99, and we're going to use, it looks like we're using .5 all the way through here. So that is going to be the virtual IP. Now, let's also put in here standby 99. We need to have preempt. Because this is going to ensure that if this router needs to preempt and take, or this multi-layer switch needs to preempt and take back over for VLAN 99, that it can do so. Now, we're going to kind of spice these things up a little bit here. So this is something that I always use, right? And we talk about, you know, if you have a link flapping or maybe something's broken, where you could have a link that's flapping and coming up and down, I always like to put in a delay. So how long do I want to delay before taking back over? So standby 99 preempt delay, the minimum amount of time I'm going to wait, and I typically use, and I believe the best practice is, I'm trying to remember the equation, it's something like 70 or 50% of the time it takes the switch to boot, in addition to the time it takes the switch to boot. So typically on these switches, you're looking at a 3-minute, 180-second time, right? So 50% of 180 would be 90. So 180 plus 90 gives us 270. And this is a Cisco best practice to set the delay to equal 50% of the time it takes the switch to reload plus the time it takes the switch to reload. So minimum delay 270, and then we can actually do a delay after the reload, and we'll set that also out to 270, and then wait for IP redundancy of clients. We don't need to worry about that. So, but that's how we're going to spice it up a little bit there, right? So we're going to add a delay in, because you want to make sure that before this multi-layer switch preempts and takes over, that we are in a stable state, and that 270 seconds is definitely going to allow us to get into a stable state or make it apparent that we have an issue. So the priority, we're going to put 110, right? So the default priority for HSRP is 100. This is going to ensure that DLSW01 for VLAN 99 will end up being the HSRP Active. So remember, with VRRP, we had virtual routing master as well as the virtual router backup, right? So we had the virtual router master, the virtual router backup. With HSRP, it's simply the HSRP Active router and the HSRP Standby router. All right, so that takes care of VLAN 99. So do show run interface VLAN 99, and that's what we look like right there. Now, we are going to be doing some other things here where we're going to be doing authentication and a couple other nice little add-ons, but those come along a little later. So let's go ahead and get into interface VLAN 10, where we're going to say IP address 172.16.10.1. Now remember, this is the IP address of the switch virtual interface. Nothing to do with HSRP yet, so let's go ahead and get that. Standby 10, IP 172.16.10.5. Then we're going to say standby 10 preempt, right? We got to make sure we have the preempt. And the preempt statement needs to be on both the primary, right, or the active HSRP node and the standby HSRP node. It needs to be on both. Standby 10 priority is going to be 110. So now let's go ahead and take care of interface VLAN 20. We're going to say IP address 172.16.20.1. And now let's do the HSRP config. So standby group 20 IP is going to be 172.16.20.5. And then we're going to do the standby preempt and our priority. Standby 20 priority 110. All right, and then into interface VLAN 30, where we're going to say IP address 172.16.30.1. And then now we're going to set up our HSRP. So we're going to say standby 30, and you can see that the we're transitioning here into the active because the other node, so the node that's going to be the standby node, hasn't been configured yet, at least for VLANs 10 and 20, as well as 99. So we've got standby 30, and let's get our IP address. I'm sorry, standby 30, IP address. Did we get that 30.1? We did. So now we need the HSRP IP address of 172.16.30.5. Now, we're going to do the standby preempt, but there is no priority. So remember that when the priority is not specified, right, not manually entered in, that it's 100. So above here, what we're saying is that on DLSW01, it's going to be the HSRP active node, and we just went active there. It's going to be the HSRP active node, and it's probably going to be easier for me to say do show HSRP brief. Do show HSRP, do show, I'm trying to remember here, show HSRP, or show standby, sorry. I always want to say HSRP. Show standby brief, there we go. I always want to say HSRP instead of standby. All right, so as you can see here, we've got VLAN 10, 20, 30, and 99. We've got one more to do. We're gonna jump back to that here in a second. But when we take a look here, you can see indicates configured to preempt, right? Well, VLAN 30, we are configured to preempt, but nothing else is configured, and especially on the other side, right? So we are the primary with 110 as our priority for 10, 20, and 99. And we're going to talk about the spanning tree considerations as well here once we knock this out. So let's go back into global config interface VLAN 40, and we're going to say IP address 172.16.40.1/24. And now let's get our standby 40 IP address 172.16.40.5. And now we're going to put our standby 40 preempt statement in. Again, remember, we have to put the preempt statement on both the active and the standby node, or else it's not going to take over automagically for us. As we saw in that other video, one of the previous videos I did, you can end up with a split brain scenario where both routers believe that they are actually the primary node. All right, so we've got the preempt in there, and so that does it for, let's go ahead and save our config here. Do a write mem and save that config off. And then let's take a quick look. So show standby brief, and that's what we have right now. And actually, did I put, I did put preempt in there. Did I miss that on show interface VLAN 30? Did I not put that in? Show run interface VLAN 30, and let's see, and fortuitous failure here, right? When you forget to put the group number in, HSRP by default is going to put in 0. It's going to think it's group 0. So let me go back into VLAN 30 here, and let's say no standby 0 preempt, and then let's say standby 30 preempt, because we should have that on all of them. All right, that's a little better there. So for 30 and 40, DLSW01 is not going to be the active router. It's going to be the standby HSRP router. Show standby brief, and now we look much better. And you can see here for VLANs 30 and 40, we are going to be the standby because our priority here is 100. I'm assuming that on DLSW02 we're going to be setting it to 110 for 30 and 40. So let's go ahead and take a look at that now. Let's jump over here to DLSW02. We'll go from user exec to privilege exec into global config. Remember, we're doing inter VLAN routing here, so we need that IP routing command on the multi-layer switch to make that happen. We're going to go ahead and put the loopback on here as well, interface loopback. And this is actually a typo in the lab. So in the lab, it looks like they cut and pasted from the beginning of step 7. The first thing that you do is you set the interface loopback to 100, and it shows DLS 1. But when you get down to the DLS 2 configuration section, it's actually showing you DLS 1 again. However, the statement at the very end says both DLS1 and DLS2 will have this loopback configured. So since we're doing all our configuration here on DLSW02, that is definitely going to be where we're going to configure the loopback as well. So 165.200.254, and this is /24. All right, so now we're back into the HSRP config for our VLAN. So we're going to say interface VLAN 99 IP address. Now remember, we're on DLSW02, so instead of .1, 172.16.99.2, we're going to be using .2. And this is going to be a /24, let's say 255.255.255.0. So now we say standby. And actually, before we do this, let's go ahead and make sure that we can see debug standby. I won't type in HSRP again. Debug standby. And let's see, we should get everything with this. So if we take a look here, you can see our virtual IP is listed over here. We've got our priorities. And so every 3 seconds, and I'll let this go one last time here, we'll say you all to kill the debug. So every 3 seconds, our HSRP hello packets are getting sent out to 224.0.0.2. That's the HSRP address, multicast address that the routers are listening to. As soon as you enter in that first standby command, they start listening. So if we look at VLANs 99 and 20, we can see that the message time here was 1:04:48. The next time VLAN 99 and 120 come up, again, right about 0.971, so right about 3 seconds. We'll come down and take a look again. Here's 99 and 20. And from 50:51 to 53. So again, it's not going to fall out exactly down to 3 seconds, but it's going to be pretty close, right? So every 3 seconds, HSRP is sending hellos. Now remember that it is a 10-second dead timer. So it's 3 seconds on the hellos, but for whatever reason, the dead timer is 10 seconds. And the best practice is, if you're going to manipulate these timer values, is that you always ensure that the dead time ends up being 3 times more than the hello time. So if I were to set the hello time to 1 second, we would want to make sure that it's either 3 seconds or greater than 3 seconds. So 3 or 4 or 5, right? But again, as long as it's 3 times greater, we're good. And we're going to talk about tweaking these down to the millisecond in a few moments here. So let's get that debug. Let's kick the debug off here again. But we're going to say debug standby. And I'm going to say we want to see errors. We want to see events. And I want to make sure that just in case, events and not terse. So the packets we're going to leave off for right now, because the hello packets we've got an idea there above of what that's going to look like. So, but we want to go ahead and say show debug, and there we go. So we're looking at errors and events. So let's come over here. We're at VLAN 99. So standby 99 IP. So what is the virtual IP? Well, this is the same IP that we defined on DLSW01, right? It needs to be the same IP. In fact, what if I said .6? And then let's say standby preempt. And again, we are not the primary. So let's see what happens here. So check this out. Group 99, active routers, virtual IP is different from the locally configured setting. Let's see. We've got when this lights up blue in secure CRT, something's going on. So let's see what we've got on the debugs here. So the debugs come back, VLAN 99 group standby router. So it's telling us the standby router. It's no longer passive, and DLSW02 is the standby for router 2. I was hoping that we would see, and actually we've got the VLAN 10. So I didn't want to see the VLAN 10. I was hoping for VLAN 99. And it's interesting here that we're not seeing anything telling us from these debugs that it's conflicting. So what if we said do debug standby errors over here? Do we see anything about the HSRP address being different, right? So we've got a problem here where we've got mismatched addresses. We're getting the syslog, but interestingly enough, we don't see much of anything from our debug, which is okay. So let's go ahead and do this. We'll simply say no standby 99 IP 172.16.99.6. And we're in the disabled state right now, so now we're going to come back with standby 99, and let's properly configure it, 172.16.99.5. So do show run int VLAN 99. And we need to make sure we get that preempt statement in there under the right group. I constantly do this, unfortunately. No standby. I always forget to put in the group number. So no standby 99 preempt. We'll do a control U there, and we'll say standby 99 preempt. Yeah, I was in such a hurry to type the preempt statement in after misconfiguring the IP that I forgot to put the group number in there. So we've got the right group. So now we go from speak to standby. So remember, we're in the standby state. So do show standby brief. And we've only configured one group over here. It's group 99. You can see that we are in the standby state. You can see that preemption has been configured. Who is the standby? The local node is the standby node. If I come over here to DLSW01 and say show standby brief, you can see for VLAN 99 we've got everything set. It says active. Who's the active node? Well, the local node is the active node. Who is the standby node? That's DLSW02, and then here is our virtual IP. And DLSW02 is the standby by virtue of the fact that DLSW01 has a priority of 110. If I were to say show standby all by itself here, and actually we can say show standby, I can trim this down a little bit, show standby, and we want not all, not for the neighbor, we want VLAN 99. So I only want to see VLAN 99's output. So let's take a look here. Again, we're dealing with group 99, so this is everything, right? Group 99 for VLAN 99. Now, these do not have to match. However, it is a very, very good idea to match them up so that if you have to troubleshoot this, it doesn't become more complex than it needs to be. What is our state here? We are the active HSRP router. We've had 2 state changes, right? The virtual IP that I'm masquerading as or responding for is 172.16.99.5. That's going to be that default gateway address. The active virtual MAC address. So here it is again. Now, Alpha Charlie 63. Where does that 63 come from? You can see version 1 of HSRP is the default. So where does that 63 come from? Remember that this is a MAC address, so this is going to be in hexadecimal. So it's nothing more than the group number we configured, which was 99 in hex. So if we said 99 in decimal, how do we get to hex? Well, we simply convert 99 into its binary form consisting of 8 bits, right, or an octet. So it would be 128 would be off, 64 would be on, 32 would be on. That gives us 96. Well, now all I need is 3. So if I take 2 and 1, that's going to give me 3, right? So in binary, that is what 99 looks like in binary. So then how do we get to hex? Very easy. Just draw a line right down the middle there. And what's the value in here? 4 plus 2 is 6. And what are the values in here? Again, the values being 1, 2, 4, 8. Because we're talking about a nibble. 1, 2, 4, 8. And then 2 plus 1 is 3. And that gives us that hexadecimal value. Very, very straightforward. But again, up until the last 2 hex characters, and here's what we'll say, each of these hex characters is 4 bits, right? So 16, 16, and 8. So what is that? 20, 16, 16, 32, and 8 is 40. So the first 40 bits are going to be set, or I should say the first 10 hex characters are going to be set as 0000 dot 0 Charlie 07 dot alpha Charlie, and then XX. And the XX will be the hexadecimal value of the decimal group number. And this is exactly how you get it. You go from decimal to binary with the, just like you're doing your IP addresses, right? You're trying to figure out your IP addresses. And then you convert that to hex by just splitting that octet in half. And then you've got two values here based off of the way you convert from binary to decimal, and then that gives us our values down here in hexadecimal. All right, so let's clear that off here. All right, so we've got VLAN 10 is doing something. So we'll come back here. You can see hello time, 3 seconds. The hold time, 10 seconds. It even tells us when we ran the command how many seconds we have until the next hello. Preemption is enabled. Now, here's my delay. Is a minimum of 270 seconds, and on a reload, it's the same thing. So if the router got rebooted, right, we would wait 270 seconds before we attempt to take back over. And if we lose the active status, right, so let's say that for whatever reason we lose the active status, we're going to wait 270 seconds before we attempt to take it back over. The active router is the local router. So this router is the active router. Who is the standby router? Well, that's going to be DLSW02. There's his priority. And the expires, right? If you take a look at the hello time over here, right? We were going to get the next hello in 0.272. Well, it would expire, this neighbor relationship is going to expire in 9.232 seconds. Because again, remember, 10 seconds is the dead time. So what is my priority? Well, it's 110, and that shows me the current priority. We'll see if we're tracking interfaces that this may drop. And then you'll see that we're configured at 110. So this is the statement we put in there, standby 99, priority 110. And this reflects the current priority. This is the configured priority. This is what it currently is. Once we get into decrementing, you'll see this will change. So the group name, and this just gives us this HSRP-VLAN 99-99, that is the name of the HSRP group. All right, so that's a nice overview of the HSRP values. And again, we've only configured just this one here. So let's knock the rest of these out. Let's get an interface VLAN 10. Let's say IP address 172.16.10.2. This is going to be a /24. We'll get all this configured up here. And for VLAN 10 on DLSW02, we're going to say standby 10. IP is 172.16.10.5. And then standby preempt, because again, we are not the primary, so we're not setting the and I said standby preempt again. I always forget that. It should be standby 10 preempt, and then we want no standby preempt. So do show run interface VLAN 10, and there we go. So we're looking good. So interface VLAN 20, IP address is going to be 172.16.20.2. And again, this is the IP on the switch virtual interface. That is not the VIP or the virtual IP that floats back and forth. So we'll say standby 20 IP 172.16.20.5 and then standby 20 preempt. And again, we are not the active router for 10, 20, and 99, but we are for VLAN 30 and 40. So interface VLAN 30. And let's say IP address is going to be 172.16.30.2. And let's get that subnet mask in there. Now for the standby activity. So standby 30 IP is going to be 172.16.30.5, standby 30 preempt, and then standby 30 priority is going to be 110. Because this is going to be the active node. So now let's watch. You saw how group 20 said speak to standby. Now look, it went from disabled, and then we enabled it with the preempt or with the standby commands for VLAN 30. Now it moves into listen, and take a look. What was he listening for? Well, he's listening to those hellos coming to multicast address 224.0.0.2. And what those hellos say, and what we saw over here earlier when we were doing our debugs, is in these hellos, it's communicating the priority value. And so by virtue of the fact that DLSW02 is sending hellos that have a superior priority, it's going to transition from the listen state, right, listening to the other hellos for group 30. He determines that he clearly has a higher priority value, which is 110 for group 30 than any other router participating here. So then he moves into the active state for VLAN 30. Let's wrap this up now. Interface VLAN 40. And we're going to say IP address 172.16.40.2. Let's get our subnet mask in here, /24. And now come the HSRP commands. So standby 40 IP 172.16.40.5. Standby 40 preempt. Standby 40 priority 110. Okay, so let's go ahead and say write mem. We've got a lot of work here that we do not want to lose. And you can see right here that I went from active to speak for VLAN 40. Now, what should happen, and fantastic. So the standby timer expired, so standby router becomes the local router. So DLSW01 says that I'm moving from speak to standby because I'm seeing that I'm receiving a superior hello packet for group 40. And there's our HSRP state change. We go from speak to standby. And let's see, we've got, that's it. So good. All right. So we're good there. Let's save our config here. I can't remember if I did, but we'll do it just in case. So now what we're going to do is from host A, and let's take a look here. This MacBook's going to get a workout. So this is going to be host A for right now. And host A has an IP of 172.16.10.100. It's a /24, and there is the default gateway. And so his default router is the HSRP address that we had just configured earlier. So let's see. Can this host ping 172.16.10.5? Again, it's that virtual IP that's floating back and forth. And take a look at that. I gotta love the debugs. I tell you what, I really, really enjoy the debugs. We've got HSRP VLAN 10, Group 10, and take a look at this. ARP source. So the MacBook had to ARP for the address, right, to try to get that layer 2 information. I said ping 172.16.10.5, and so I didn't have it in my ARP cache on the MacBook. So the MacBook sends an ARP packet out, address resolution protocol, asking, hey, I'm trying to get a hold of 172.16.10.5. I've got your layer 3 information because it's been given to me in the ping command. However, what is your layer 2 information so that I can communicate with you? And that's where we get this nice debug right here, kicks it back, and DLSW01, who is the active / primary HSRP router, replies with MAC address 0000.0charlie07.alpha Charlie, and then there it is. That is 10 in hexadecimal. So 0A is going to be 10 in hexadecimal. So we get our group number there at the very, very end. All right, and this is great that we saw exactly how it's going to reply back. So let's transition back over here to the MacBook. So everything looks good there. So now what we're going to do is we're going to start a continuous ping. We're going to see, can we ping 209.165.200.254? And we can. And take a look at that again, right? The ARP cache had timed out, so we needed to get the layer 2 information from the provided layer 3 information in the ping command, and the active router responds back with the MAC address And you can see there, it continues to respond back with the MAC address. So we've got this continuous ping going here, and now what we're going to do, we're on step 7 still. Let me make sure we've got this here. The following host A, analyze loss of connectivity. All right, so it looks like we're going to let that continue to go, and we're stepping up here onto, we're moving along here to step 8. So we took a look already at that show standby information. And this is interesting too, because I believe this is a typo as well. On DLSW01, when we say show standby for VLAN 10, or for group 10, I should say, it shows the priority that's configured as 150. But we've never configured the priority for 150. The priority was always configured for 110. So just take note that they've got something highlighted there talking about priority 150, but that is not what we set. Okay, so we'll skip over step 8 here. We've already looked at the briefs. So the question is, for VLANs 10, 20, and 99, the active router is DLS1. For VLANs 30 and 40, the active router is DLSW02. So what is the default hello time and the hold time? We talked about that, 3 seconds and 10 seconds. How is the active HSRP router selected? So it's the highest priority, which we've configured as 110, and if the priorities are the same, it's going to be the HSRP router with the highest IP address on that segment. All right, and so we end up here at the end on step C here, sub-step C in step 8 of the lab part 1, where it just wants to show IP route. Right, so here's the routing table right now. Not much to report here on DLSW01. We simply have the directly connected VLANs, right? And if we were to take a look at DLSW02, show IP route, we simply have our directly connected VLANs. Now, let's talk real briefly about something else. If I say show spanning tree, right? Or let's say show spanning tree route. Take a look for the VLANs that we're using with HSRP, in other words, VLANs 10, 20, 30, 40, and 99. Is this the root bridge for any of those VLANs? And it's not. We know it's not because we have a cost value here to get to the root. So again, when we take a look at the drawing, or I should say our diagram that we have here, we need to talk about this for a second, because it's a best practice that if this is the HSRP active, or we'll say primary, like it is for VLANs 10, 20, and 99, do I want that to be the root bridge for those VLANs? And the answer is no. Whoever the HSRP active or primary node is going to be configured as, they should also be the root bridge for those VLANs. Because again, in our layer 2 topology, we don't want traffic originating here to have to come up here from the layer 2 perspective and then traverse that link to get to the default gateway. Which, if this is the root bridge, then this would be my root port right here. This would be the designated port, and one of these ports over here is going to be most likely in the blocking state, but this root port is going to tell me I'm going that way for my traffic in all VLANs right now. Because 6680, which is DLSW02, that is the root bridge at current. You can see 6680 is the root bridge. So best practice, it doesn't mention it here yet in the lab. It very well may, but let's make that happen, right? Let's make sure that we're not having to jump from, and let's see, we're on ALS1. If we were on ALS2, up to DLS2 and then across to DLS1, if that's the way we're trying to go. So let's go into global config. Let's say spanning tree, and we're going to say spanning tree, sorry about that, spanning tree VLAN 10, 20, 99, and I'm going to say priority 0. And then just as we are the primary for these, we're going to put ourselves as the backup for 30 and 40, and I'm going to say priority 4096. And now let's go over to DLSW02 and let's affect the same change. We'll go into global config, say spanning tree VLAN 10, 20, and 30. Priority is going to be 4096, right? Because we're going to be the backup, right, of the secondary root bridge. And then spanning tree VLAN 30 and 4. Oops, and I think I messed up there. It was 10, 20, and 99. 10, 20, 99, 30, 40. So we got it right there. So we'll say 30 and 40, priority 0, and I'm going to say no spanning tree, priority 4096. Let's say copy and paste here. And let's say spanning tree VLAN 10, 20, 99, priority is going to be 4096. So let's go ahead and do a quick do show run, include spanning tree to make sure that we've got everything in here that we want. And we need to add spanning tree VLAN 30, 40, priority 0. There we go. Rerun that command and we should see 30 and 40 in there. All right, and that's what we want. Because again, if DLSW02 is the HSRP active node, right, configured active node, that is who we want to be the root bridge for those same VLANs for which he is the active node. And we'll make him the secondary root bridge because he's the standby HSRP node for those VLANs. And then same thing over here. Let's type in, we'll save our config and write mem. All right, so now we are going to go to step number 9, where we're going to configure connectivity between VLANs. And actually, let me see real quick here the ping command, but where are we pinging? Okay, we're going to shut some interfaces down. All right, so now what we need to do is on DLSW02, because we're dealing with VLAN 40, and that's going to be host D. So let me switch the cable connections here on the MacBook. And we should see here on DLSW02 that FA606, and there it is. Our host is now plugged in and has come up. However, a minor change, you'll notice we lost all of our connectivity there. Minor change is that we are now on VLAN 40, and so it's as simple as that. And let's click apply. All right, now remember we had that continuous ping going here, so let's see and take a look at that. So we've got the ping going, and this is actually what step 9 is asking you to do. So we've got our continuous ping going here, and now what they want us to do is on step 10, we want to verify HSRP functionality. And how are we going to do this? Well, I'm going to shut down all of the interfaces on DLSW. Oops, let's stay in here. On DLSW02. So let's go into global config interface range FA607 through 12. And I'm going to say shut. Now, as soon as I hit enter here, we're going to jump right back to the PC and I'm sorry, I should say the Mac, and let's see what happens. Do we miss anything? I just shut down all those interfaces and not a single ping packet did we lose, right? And this is really the benefit of HSRP, right? It's all about first hop redundancy protocol, right? So look at that redundancy. I did not drop a single ping. So if we transition over to DLSW01 and say show standby, excuse me, show standby brief, you can see now that we are no longer the standby node for VLANs 30 and 40. We are the active node, right? So what is the state for VLAN 30 and 40? It's active, and who's the active node? The local node. You can see we shut all the interfaces down on DLSW02, so everything shows as unknown. We still have the same virtual IP that we had before, and take a look, we've got our priority statements here. Priority on the local node is still set to what it was. So everything did exactly what it was supposed to do. And now let's go ahead. We're going to bring the interfaces back up for or actually, we're going to bring all of the interfaces back up here, and give me 1 second. Make sure if DLS1 have links to the internet. Okay, so we're going to transition back to host A after we transition back. So it says repeat the process by bringing up the links on DLSW02. So let's squeegee that off. We'll come back over here. We're already in the interface range. Now we're going to say no shut. And we transition back to the PC. And let's see, do we lose any packets? We don't. We had a definite 43 milliseconds there, right? So that was during the transition, but we did not lose any of the packets. We'll come back here to DLSW02, say do show standby brief. And you can see the state is in init, right? And all we know right now is that for VLAN 40, we are the active local. So let's continue to watch this. And you can see we've got to wait for the VLAN interfaces to come up. So now that those VLAN interfaces have come up, we're in the listening state. We're listening for the HSRP hello packets that go to multicast 224.002. And take a look. Now we're in the speak state. And we're going to transition here to the, there we go, to the standby state for groups 10, 20, and 99, which is exactly what we wanted to have happen. So let's take a final look here. And there we go. DLSW02 for group 30 and 40 were the active. Let's go back to DLSW01. You can see we have some good debug activity here. Show standby brief. And there we go. So the final thing we're going to do now, it says go back to host A, which for us means unplugging host D and plugging in the cable on ALSW01, and the ping should still be running. Well, we had to unplug, and so if I were to go back and the ping's not running because obviously we're in a different VLAN, but if I were to change this, let's see, is it still working? And click apply. And let's see what we've got. Bingo. Perfect, right? And there's our debugs picking up the ARP requests and replies for group 10. All right, so now we're on step 11, and this is going to wrap things up for us here. We're going to be doing HSRP authentication using MD5. So on DLSW01, we're going to go into Global Config, Interface VLAN 10. It looks like we may only be doing VLAN 10. Now, when I say standby 10 authentication question mark, we can do plain text authentication, or I can use MD5 authentication. So we're going to say MD5, and just like the activity we did Discovery 15 for VRRP, we could do a key chain, or we can do a key, excuse me, or we could do a key string. So let's go ahead and take a look at the key string. And again, we just simply type in whatever we want the password to be. So we'll say Cisco 123, or I should say whatever we want the hash to be. Shouldn't say password. Want the hash to be. Now we're going to see that error again with bad auth. And take a look at that. The debug picks it up. Syslog picks it up right here. There's our debug catching it. And you can see now that for VLAN 10, group 10, authorization failed, right? MD5 configured, but no type length value. So again, we are not receiving, and this is pretty rough here, neighbor destroyed. So it looks like our do show standby brief. What do we look like for VLAN 10 now? Well, we show that we're the active and the standby is unknown. Well, let's come over here to the standby. Again, you can see here we're getting a hello packet, but the authentication is failing. So if I say do show standby, what is my state? Well, exactly. Now I think I'm the active node for VLAN 10, or for group 10, which is VLAN 10. And so this is what we like to refer to commonly as a split brain scenario, where both distribution layer switches believe that they are the true active node. So if I were to come over here to And I guess let's go to ALSW1. We're plugged in here with that with the MacBook. We'll go to Privilege Exec, Show MAC Address Table Dynamic, and here we go. So now it says to go out port channel 1, and in fact, let me trim this down to VLAN 10. So it says go out port channel 1. Let's see, does it flop at all or flip back and forth? And we saw that with the earlier VRRP exercise. Let's see what we see here. Show MAC address table dynamic VLAN 10. Show MAC address table dynamic. There we go. And it says to go, and again, different port channels on these switches. So this is saying to take port channel 2, right? Because DLSW01 that's the port channel that goes from ALSW2 up to DLSW1. So that's correct. Now, and that's because it is set as the root bridge. So for VLAN 10, we keep taking a look here, and it doesn't look like it's going to flap. And again, this may be the difference because we have our root bridges configured properly, whereas before we had routers, they were plugged in, we really didn't do anything. We had both switches were, or one switch was the root bridge for everything on the other activity. So let's go to DLSW02. Let's sort this out here. We're going to go into interface VLAN 10, and we're going to say standby 10 authentication MD5, and we're going to say key string, and it was just Cisco 123. So let's see what happens now. We'll come over here where we've got some debugs going on. And you can see that we went from active to active, right? So we already thought we were active, and you can see here our neighbor DLSW02 is no longer passive. He is the standby. So that completely sorted that out, and everything looks really, really good. All right, so we've got our authentication configured. So if I were to say do show standby, not brief, do show standby VLAN 10, we should see that authentication is MD5 key string. Now we've got step 12 here is our interface tracking, because again, HSRP, Cisco's proprietary first hop redundancy protocol, has built-in native tracking abilities, right? So we can track HSRP interfaces. But what if you didn't want to track an HSRP interface? What if you wanted to track reachability to a destination? Well, it's easy to do. We can use IP-SLA to do that and create just an enhanced tracking object. And so let's go ahead and do that. We're going to do it on DLSW01. We're going to track that that internet address at 209.165. So I would just simply say IP-SLA 10. And how am I going to track it? Well, I'm going to do ICMP echo, which means I'm going to ping it 209.165.200.254. How often? We're going to ping it every 3 seconds. And then what's my can't be less than my timeout. All right, so we'll say 9. So frequency 9 seconds. And then what's the schedule going to look like? IP-SLA schedule, and I need to back out one. IP-SLA schedule, there we go. And that's a typo in the lab. They show that IP-SLA echo sub-configuration mode, but you need to back out. So IP-SLA schedule, so my schedule is, and that number right there is simply just the entry number to identify the schedule, right? And the life is going to be forever, and the start time is going to be now. So we'll back out. Oops, sorry. Go back into global config here. So I'm going to say track 100, and let me make sure why they're using. Trying to figure out why they're using track 100. So I could say track 10, but we'll stick with this. Track 100 IP-SLA, and we're tracking service level agreement 10, which is that ping command. So we'll go into interface VLAN 10. And I'm going to say standby 10 track object 100, right? And if something happens, right, where I lose track of that, I'm going to decrement by 70, right? So I'm decrementing the priority that I've set, which is 110, and I'm decrementing it by 70. Now, I don't have to choose 70. I can choose anything as long as I lower it below the priority of the standby node. So in fact, I could say decrement 11 to make it 99 if DLSW01 for group 10, VLAN 10, loses reachability. All right, so let's go ahead and save this off. So we'll say, and you can see right here, that's fantastic, right? The debugs help us out. So we tracked object 100. We're going to start tracking, right? So group 10 is tracking that object. So if I were to say show IP SLA, and I want to see show IP SLA statistics, right? So there is, or there are the statistics right now that we're running for index 10, right? Round trip time is 1 millisecond. The return code is okay. We've got 11 successes. We've never had a failure, and it's going to live forever. So let's go ahead now, and on DLSW01, we're going to go into global config interface, loopback 200, and we're going to say shut. So we should see some activity here shortly telling us that the tracking state, right, that it's got an event here and that we're tracking that IP. And there you go right there. Perfect on the debugs, right? IPSLA 10, the state went from up to down. So the tracking object went from up to down. So our priority goes from 110 to 99. So then take a look here. Node 2, right? Neighbor 172.16.10.2, that's DLSW02, is no longer the standby for group 10. He is now active. And what about the local router? Well, it's gone from active to speak. And we ultimately end up at standby. So let's take a look at everything that's happened here. So when I say do show IP SLA statistics, what do we have? Well, the last return code was a timeout where now the failures are incrementing, right? So the latest round trip time is no connection, busy, or timeout because, again, before, what did it say before? It said 1 millisecond. Well, now that interface that we were tracking is down because if that interface were to go down prior to us doing this, HSRP wouldn't naturally be able to tell that a remote hop is no longer available. So we're just helping HSRP make that determination with an enhanced tracking object. And you can see that, you can see that the node, the MacBook, is still pinging here, but it's disallowing the reply. And this is fantastic because what is that ARP request asking for? It's asking for the layer 2 information, the MAC address that corresponds to this HSRP group. But what is DLSW01 saying? He's saying, no, I am disallowing the reply to this because I am not the active HSRP node anymore. So do show standby brief, we would expect to see that for VLAN 10, group 10, our state is standby, right? Because we have decremented our priority by 11, taking us to 1 less than DLSW02, who over here is do show standby brief, who is now the active node because his priority is configured for 100. We left it as the default. So when I decremented the priority for group 10 by 11 on DLSW01, that meant that DLSW02 with a higher priority, remember those HSRPs flowing back and forth to 224.002, DLSW02 sees, hey, wait a second, my priority is higher than the priority now of DLSW01 for group 10, therefore he takes over. In fact, remember we looked at the do show standby output earlier, and actually good, 10 is first, so we'll highlight it here. So take a look, what do we see? Well, what we see now about the configured statement earlier, so the priority, the current priority is 99. The configured priority is 110. So if you were to be asked, what is the decrement value for that object being tracked, you'd simply subtract 99 from 110, which would give us 11, and that's what we dropped it by. And you can see right there, track object 1. And that is the object, and now it's kind of scrolling by there. So that is what we were tracking. So again, you can see the active router is now router 2, DLSW02 with a priority of 100. Now remember, we're going to go ahead and bring this back up right now. Remember what we did. Remember what we did. Do show VLAN, do show run int VLAN 10. Remember what we did here. Or did we not do that on VLAN 10? I thought we put in a delay. Did we do that? Oh, we did it on VLAN 99. So we're not going to see the 270-second delay, which I won't make you wait through. So let's go ahead and bring the interface back up, right? I'll say end, and let's see what happens now. So the loopback comes back up, show IP SLA Statistics. So it's coming back on, right? Latest round trip time, it's back up. Return status is now okay. And so take a look. We went from standby to active. We are in the active state. DLSW02 is no longer passive. It is the standby. So let's say, and now we're replying, right? We're not disallowing the replies, right? We're no longer disallowing the replies because we're not active. Hey, we are active and we are replying, right? Here is the MAC address that corresponds to that default gateway layer 3 address. So if I were to say show standby, you can see that we are the active router now for group 10. Priority is 110, configured as 110. Track object is 100, right? That's the 100 number. I was looking for the 2 zeros earlier. They weren't there. And the state is up. And if something goes wrong, we will decrement by 11. Okay, so here's what I'm going to do. I'm simply going to go ahead and kill the recording here. And then we're going to pick up on part 2 in another video on VRRP. All right, so stand by, and we're going to be in the next video here shortly. Thanks for watching.